Now that we've seen how to solve inverse normal problems using the tables, we can also look at how to solve them using the calculator. Now, unlike solving the last types of normal curve problems on the calculator, it turns out that this is not always going to be easier than doing it using the tables. It really depends on the problem, but there is a little bit of extra work involved sometimes depending on the type of area when you're using the calculator to solve these problems. But first we'll start with the general steps you're going to take. Then we're going to go through all the examples in the last video, but we're going to be doing them with the calculator. So the first thing you would need to do is hit your second button and then vars to get to distribution, same as last time. So first we would hit second, then we're going to hit vars, then you end up over here. Now before we were going to normal CDF, now you're going to choose your third option which says inverse normal. Then we'd hit enter. Now you should see something like this. Now what you're going to input is the area to the left of whatever value you want to find, the mean of the normal curve or normal distribution you're working with, and the standard deviation of the normal distribution that you're working with. So if you're working with a standard normal curve, this is going to be 0, that's going to be 1. If the problem tells you something else, you're going to put in whatever the problem says the mean and standard deviation of that is. And what we mean when we're talking about area to the left, so let's say they want us to find this z-score, and this is the type of area that they give us. They give us, I don't know, like let's say this is, 0.3, what was it last time? Let's say this is 0.3212, right? We can't just put this number into the calculator. We need to know everything to the left. So this bit is 0.5. So what it wants to know is the entire area to the whole left of whatever your score is. So we would end up having to put in total area to the left. Right, we'd have to add these two together to figure out what the whole area to the left is. If they give us a piece of area like this, right, let's say they give us something like this, and this is, I don't know, like 0.25 or something like that, we can't put in 0.25 because the calculator wants to know the amount of area to the left. So area to the left here would end up being 0.75. So it can be a little bit more work. If you have a TI-84, it is a little bit more user-friendly and the steps are a little bit different. When you get to inverse normal, I think it's going to ask you left, right, or center. And if you're working with the area to the right, you would select right. If you're working with a middle chunk of area, you would hit center. And if you're working with the area to the left, you would put in left. But if you have a TI-83, it only takes the area to the left. And so now we'll go look at the examples we were looking at before, but we'll talk about how we would solve them using our calculators. This is the one we had before, where we were given a piece of area between the mean and some unknown z-score. On the calculator, draw our picture again, we have to find the area to the left. We know this piece is 0.5, this piece is 0.3212, so our area to the left, so that's going to be equal to 0.5 plus 0.3212 is going to be 0.8212. Now to do this on the calculator, we would put this in our inverse normal. It's going to be 0.8212. Our mean is 0 because this is standard normal, and our standard deviation is 1. Then we would hit enter and we see what we end up getting. And we end up getting 0.919947 and change as an answer. If we look at the answer we got as a z-score, the table's only going to give us 2 digits. Your calculator is going to give you more digits and give you a more exact z-score, but we only need to round to 2 places because the table only goes to 2 places. So if we look here, 0.919, that rounds up to z is equal to 0.92. We'll go to the next problem, and we'll talk about how to solve this one on the calculator. So this one is a bit different on the calculator now. Well, we would find this z-score the same way that we had found the other one, just by isolating this piece. If we wanted to find this one, well, we could use the fact that these two have to be the same, except one is positive and one is negative. We could do that. But we could also look at how to find this one another way. But first, what we'll do is we're going to break this up into how we would find both z-scores. So we have this guy, is one that we need to find, and we would have had to do the preliminary work of figuring out this piece of area is 0.3212. We know this is 0.5, so the area to the left here is going to be 0.8212. For the negative z-score, we need to find the area to the left. If we know this piece is 0.3212, the area to the left over here is going to be equal to 0.5 minus 0.3212, which gives us 0.1788. So for this one on the calculator, we would put in 0.8212. You could even just put in directly 0.5 plus 0.3212, comma, mean, standard deviation, and we'd end up getting, again, z is equal to 0.92. If we do it for this one, we could do inverse normal. You could directly put in 0.5 minus 0.3212. Mean is 0, standard deviation is 1. You could also have done the subtraction separately and you'd get the same thing. So whichever one you put in, you should end up, let's make that look like an 8. Whichever one you put in, you should end up with the same answer. Both of these are going to give you negative 0.92. And now we'll look at the last type over here. So for this type, well, obviously this one's the easiest. If they already tell you the amount of area underneath whatever the z-score is, 0.9 is all you need to put in for your area to the left. Over here, well, they're giving us the area to the right, so that's going to be done a little bit differently. So we know that we have 10% over here. The area to the left, since the area under the whole normal curve is equal to 1, what we could do is we could do 1 minus 0.10, and that's going to leave us with 0.9. The other way we could figure out the area to the left is, well, we know this piece is 0.4 if we subtract 0.1 from 0.5, and we know this piece is going to have to be 0.5. So this is 0.5, that's 0.4. Together the area to the left is 0.9. Another way we could look at that is 1 minus 0.1. We could do other things to play with what these pieces of area are, and what we'd put into our calculator, inverse normal, area to the left is 0.9, mean is 0, standard deviation is 1. We end up getting 1.2815, and it goes on a bit longer than that. What we ended up getting before was 1.28, which is very, this is just more exact than what we had before, but essentially it's the same answer. So z is equal to 1.28 is our answer again. Now this way, this one is pretty obvious. They're already giving us the area to the left. We have our z-score. We're told everything in here is 0.9. So it was already given and we were told it's equal to 0.9. So we would put the exact same in. We would put the exact same thing in the calculator. 0.9, mean, standard deviation, and we would again end up getting 1.28 as our answer.